Welcome to another video and episode on the second series in my Arduino Mega2560 experiments. The new experiment is that I want to focus on the inductors, one inductor, and to accomplish that I thought that I need a switch, I need a transistor, and I need a safety diode. But I need more. Right now this works, kind of. At least I get pulse width modulation. Then, in order to check if the transistor works, I have a connection to the ground, I have a connection to, well, the inductor. So now I know that there is something going. However, when I look at the oscilloscope, then I can't measure anything. So, been looking at it, and then they say, in yet another advice, you have to put a resistor between the source, no, not between the source, between the inductor and ground. While one other says, no, it has to be to power. So there is a problem. Anyway, the resistor could be necessary to measure whatever is going on in the inductor. So what I need to do, take this off, put this, say, right here, take a resistor, 800 ohms, 880 I think, and then put this, I think, right here. Does this change anything? I would think so. But in order to know, I need another probe. And hook it up right here. Well, first of all, this should be 0. So what's going to happen? There's a block wave signal still on here, and here it remains 0, not surprisingly. However, even this signal gives, although a minimal, block wave signal. So I can also simulate it using SciLab. Hopefully that will work out. So with this result, I'm still not sure what the result will be, but I can at least find out whatever may or may not happen. And now I also see that this no longer works. So if I put this to the power, it works. The only thing is that this should work after I release the button. And that is not happening. So this burning comes from here, not from here. On the other hand, if so, then why does it stop with releasing the button? So that is not entirely clear. Let's move it once again. Yeah, doesn't do anything, and now it's connected to ground. So let's put it into simulation and see whatever may or may not happen. Right, so with this resistor I need to change schematics a bit. And there's no resistor in the schematics yet, so I'm adding one, and here's the difference. Normal resistor, American style resistor, European style. I'm in Europe, so let's take this one. And turn it, then make place, that one. Yeah, this is going to be an I1. Where do I put it? It is in series, so I need to make a bit space. And let's move this one up here. No, not necessary right now, neither is this one, but I don't care right now. Alright. A little better. So, that's one, and that's two. Resistor 1, and I need first save, and then from here to here, right. That attribute, well, not right now. Okay, so this is putting it to voltage. Not right now to mass, to ground, but that's okay for now. Then going SciLab, for simulation, because this one still has, I think, syntax error somewhere. I have no clue where, but that's not important right now. I am adding, where's my resistor? Here is a resistor. Rotate, yep, it's good. I have to enlarge it a bit. Put this one in place. And right, this one together, and from here to here. Save. Will this be different? Well, I first have to add a value which will be 880 right now, and then will this work better? No. So there is something really wrong with whatever it is. Unfortunately, the error message is not clear, and it has it twice to make things worse. Syntax error wherever, syntax error or column 15, but it doesn't tell me what it is, where it is, how it is. That makes it a bit hard. Although it also says, oh wait, no, line 1 of executed string, line 58 of function. But it doesn't give an error in connection, so that's confusing. That makes it quite hard to do anything, but what I also need to do from the sinks, introduce an oscilloscope. Although granted, makes not much use. When it doesn't compile, but for this I also need electrical voltage sensor. One doesn't go without the other. Well, this is more appropriate right here. And then this one should connect to this one. And this one connects to this one. Or more appropriate, to this one. I think that would be better. However, will this work? Nope, of course not. Still same thing, which I have no idea what it is about, but this gives a better understanding. Right, on with the rest. Alright, now while looking at this circuit, there is something interesting to see on the oscilloscope. So let me, before I press the button, so this one is start of the switch. Yes. Then this one is at the end of this LED, and this one is between the inductor and the newly placed resistor, and you see that the signal has changed. So right now I hold it, keep holding it, and there you get it, and then plus for a moment. Once more. What is happening? Not entirely negative. Now it's negative. Once more. And there you get it. And I'm not pressing now. Okay, pressing, keeping it pressed, release. And right now, none of the LEDs is burning. Once more. Only one LED is burning. Once again. Release. So why is this different behavior? Very different behavior. And I think it changed behaving after I put the resistor in. And I'm still holding my hand there, otherwise the LED may not be entirely visible. So this is a bit strange. With time base on at 1 millisecond, and they say it could even be higher or lower. Let's take 20 microseconds. No, let's put it to 10 microseconds. Do we see a difference? It happens too quickly. Right. 1 microsecond. This is more interesting. 209 nanoseconds. Ah, see. This is better. This shows what's really going on. So charging, releasing, charging, releasing. So indeed, with a very short 200 nanoseconds time base, you can see that charging takes time, and when you release, there's a very short counter pulse, and not even consistent. And I don't even see the influence of the pulse modulation in there. But the time base may be too short for that one, because here you can only see one, and pulse modulation you see more of that, up and down. So you really need a very short time base for this to function properly. Right. And when you find out that two probes may connect unintentionally, you may get false results. This probe was incidentally connecting to this one through here. This is a part where the mask connects to correct results. When it connects here, things may be very different. Look at this. Ground. So let's measure again. Alright. Do I get the same results anyway? Well, this is burning now. This one. Not much, but it is. So that's a very different idea. And if I shield it, yeah, that is a very different point of view. So let's change the time base a bit. From 200 nanoseconds, 500 nanoseconds, 1 microsecond, 2, 5, 10, 'So this is an interesting view, and releasing the button gives this. So there's definitely a different signal at work. But it still is the question, what effect does the inductor have? And the inductor is this wave. Right, now let's indeed put this one again to ground. What effect does this have? Well, I can only see here something. And that is after the inductor. So between the LED and the inductor there's nothing. And I have to be careful not to ground it. Alright, let's change the time base again. Now, it's flat out. So putting back to power again. Yes, there's change. But does it have influence on something that would be in the core of the inductor, as my original idea was? I cannot possibly tell right now. Also because this is of course DC, not AC, despite the block wave of the pulse modulation. So the only thing I can do is put something in it and have a test, but then again I would have to put it flat and see whatever happens. So yeah, I expect nothing, but who knows. Right, very short one. Taking something that is originally a jump wire, putting it inside, what's going to happen? Well, nothing as expected. Therefore I think this is not a very clever way to get something move from an inductor coil. Nice idea, but unworkable. So even the signals are the same. No nice or unexpected surprises in the signals anymore. Just flat out. So the other thing is that I wonder about is the original idea, also taken from the internet, is that if you release the power, then it gets a voltage back. Hence also this diode, which should limit the danger to the circuit. This diode also, it is a light emitting diode, so that one is passing through. The other one towards the direction towards the transistor is blocking. But anyway, you would get a pulse. Wait, how to measure that? Yes, by putting a probe here. Of course, that's how you measure a pulse. However, I am measuring a pulse now here already. And let me change this time base again. 1 microsecond. Let me go back to nanoseconds. 500 nanoseconds. Shorter. 10 nanoseconds. If it is a very short pulse, then you would see something. Okay, this is minimal, the shortest that is to be seen, and I can't see a thing. So even the backlash of the voltage is not visible. Okay, I didn't expect that one. So how to continue? I don't know. I have to rethink. Right, so a short segment turns out to be longer anyway, if something comes up. Not the result that I had hoped. A simulation that still doesn't work. 3 points to probe and unexpected practical ideas or practical results which contradict so far the theory. So what to do? Well, we'll see next time. For now, thank you for watching. If you like this video, please subscribe to my channel, give the video a thumbs up, and leave a comment or suggestion. You can also follow me via Instagram and Twitter. Please donate if you like this blog with videos. You can donate via PayPal and Twitter, via PayPal and Wired. And you can also become a patron and have your name mentioned. Much more information under this video with my URL and anything else. Once again, thanks for watching, to be continued, and bye bye.